All right, good morning. Welcome to our opening keynote here. Excited to have you join us for another day of the Datamark Orbit Virtual Conference. We're going to start it off with a keynote here by Brooks Shannon, the Interoperability Program Manager for NENA, with the topic of You're My Best Friend, Interoperability in GIS, Forever Inseparable. I'm excited to hear this presentation as a GIS nerd myself, and look forward to what Brooks has to share with us. I do want to mention our sponsor of this keynote, Motivations, which is headed by Maureen Dykeman. If you've been in 911 for very long, you've met Maureen and you know what a force of nature she is. She put together Motivations, and they really do a good job of acknowledging the people part of the PSAP. They offer quality assurance, leadership and professional development training, operations management solutions, peer community supports, and virtual trade show hosting. If you're at all involved in the Women in 911 network, you've heard Maureen's story as well. She is inspirational, and I hear great things about their training. So we're really appreciative of Motivation's support of the keynote here and the sponsorship of the conference. And with that, I'm going to hand it over to Brooks, and we'll get to hear all about interoperability. Take it away, Brooks.
Thanks a lot, Jeff. I appreciate it, and appreciate the opportunity to share some of my views on GIS and interoperability here today. Again, my name is Brooks Shannon, Interoperability Program Manager at NENA, the 911 Association. I have been in public safety for about 18 years, starting out as a software engineer and then going to the dark side of business development and product management, always focusing on geospatial and GIS location-based stuff within public safety, from PSAP mapping to NG911 core services, to computer-aided dispatch systems, mobile data editing tools, you name it. So I'm really excited to talk about how all of that stuff orbits around this concept of interoperability, and how I really do think that interoperability and GIS, in my mind, are in fact best friends. As I was thinking about this conversation, you know, I must have been thinking a little bit about our friend Freddie Mercury. Now, this is not going to be a Queen-themed presentation today, as much as I wish it was, as much as I wish I had that outfit. Instead, though, I want to talk about what makes me about as passionate as Freddie is for music. I want to talk about my passion for everybody being friends together, everybody playing nicely in the sandbox, everybody working together to achieve the mission of public safety across jurisdictional boundaries beyond the traditional barriers that often confine them. So we're going to discuss what interoperability is as a level set. That often means a number of different things to people. We're going to talk about why standards are important. For a lot of folks on the call today, we probably intuitively understand that, but it's interesting to sometimes think about why in the world are we doing all this work? And then I want to talk about how GIS is in fact a foundation of interoperability, particularly within NG911 within the i3 architecture. And then lastly, I want to poke a little bit at the question about how do we get there, right? So let's first level set and talk about what interoperability is, and the fact that in public safety, it can mean many different things. I quickly learned, you know, that my classic view of interoperability is not the classic view of many in public safety. When we talk about interoperability, a lot of times people come back to radios. They come back to how can I have interoperable communications with agencies within and outside of my jurisdiction. That is not to diminish the importance of that. That is important. But interoperability can mean a whole host of different things. Within public safety, sometimes we talk about CAD-to-CAD interoperability. That's pretty useful too, right? Having the ability to share incident information across boundaries, and maybe if you're lucky, actually request and dispatch units from an adjacent organization or agency with which you have a MOU. But within NG911, how do we actually define interoperability? What does it really mean when we talk about GIS? Because we're not talking about GIS from a radio perspective, not at all. In the general sense, interoperability is defined as systems that interwork. Now that's high level and vague. And if you take it down to the I3 sense, this is again just Brooks's definition. This is not taken from any official NENA text and or anything of such. I think it means in the spirit of I3 that interoperability means different systems in different jurisdictions working together across those traditional barriers, as if everyone had the same system from the same vendor and it all just worked together with no barriers at all, as if PSAPs and all those systems they use were the very best of friends. So that you could share incident information, you could share awareness information, you could share additional data, heck, you could share GIS data. And there are a lot of facets of I3 that do just that. If PSAPs in the spirit of I3 were able to collaborate seamlessly and or back each other up, what's needed to do that? I3 really set out to paint that vision of saying that really any agency that has an ESI net could talk to another one that has an ESI net and help them out, provide them information. There's a number of circumstances where that can prove useful. What's needed to make that happen? Well, we need functional elements inside of the core services, and we need ESI nets that are able to talk to one another. There are a lot of different implementations of core services out there. There are multiple vendors that make ECRFs, for example, to geospatially route calls. There are a number of vendors that provide ESRPs in order to actually route the SIP call from one endpoint to the next, much less the PSAPs themselves, the call handling equipment. So, calls themselves, the media, the additional data, the emergency incident data objects, the IDOs, the log events that are generated through all of this stuff, all that stuff that gets sent across the wire needs to be interpreted and understood by all of the players that are currently participating in that puzzle. NG functional elements, PSAP systems, and even the systems on the periphery. I mean, you could extend this as far as an RMS system or a mobile app that a first responder might use. They all have to have this kind of like lingua franca that they can all speak, right? Much less they need to know where to find each other, right? So let's talk about an example of where this comes to play. So imagine you are working at a PSAP in Walla Walla, Washington, and you get a call. And the person on the other end of the line says, I just got a call from grandma. And grandma, who lives in Falls Church, Virginia, needs some assistance. She's fallen, she can't get up. So grandma doesn't call 911 in Falls Church. Grandma actually calls her granddaughter in Walla Walla, Washington. Now that poor telecommunicator in Walla Walla, Washington, unless they have access to something like the NENA Enhanced PSAP Registry and Census, which is a solution that exists today that I help manage to help PSAPs determine out of area PSAP jurisdictions and how to contact them. If they don't have something like that, they're forced to go off to a search engine and hopefully figure out in not too long what the contact number is for something like Falls Church, Virginia. NG911 fixes that. If we all have interconnected ESI nets, you can use geospatial routing through the ECRF, and you can use the forest guide to help direct calls to the correct location once you know where they're supposed to go. So you could have a telecommunicator up in Walla Walla, Washington, hand jam the address in of where that location is of the actual incident in Falls Church, transfer it, and have it geospatially transferred using GIS data that was aggregated up to the forest guide in the form of service mappings to the correct PSAP. That's pretty awesome. And why we're here is to ultimately provide better emergency response, to reduce the amount of time it takes to effect that emergency response and provide a higher quality level of service. And this is how we do it. So why do standards matter in all of this? The hint is interoperability. So some of you all might know that I like beer. From time to time, I have enjoyed a nice cold one. Although maybe not as much anymore. As a child, I was enamored by trains. So I thought this was a pretty interesting intersection. There's this cafe or this brew pub in Prague that will serve beer via this little train. It drives the beer over to your table and you get your beer. I think that's pretty neat. But without standards, the gauge of that track may not match the span of the wheels on the cars. That would be a sad day if you couldn't get your beer. It would be even a sadder day if the national rail network was a series of gauges and you couldn't get your Amazon shipments, right? Standards are all over the place, from our electronics to our mechanisms of conveyance. And it's really important that we have those things so that we don't end up in situations where things are mismatched and they don't work when we expect them to work. For example, when a spacecraft is built using standard measurements and another one is built using metric measurements, and we find out in outer space that they don't actually match up. So in 911, of course, this is imperative, right? We need to make sure that systems can interoperate. Without standards, they can't. They need to speak that common language, and they very often need a consistent way to figure out who to speak to. Standards define that language. The NENA I3 standard does. The IETF standards it's based off of do that, as well as the other orbit of standards all around it. GIS can help us find the right people to speak to and can help serve as the underpinning of those standards. So let's talk about how GIS facilitates interop and how they're really bound together. GIS is not just for making pretty pastel maps, as awesome as those are. All of us know, being in the GIS and public safety space, how important GIS is to 911. And we talk about GIS in the perspective of NG 911, I think, often from a place of initial call routing and location validation. That's important. Routing is one of the big benefits that NG 911 brings to the table. More intelligent call routing, making sure calls land at the correct PSAP or the most appropriate PSAP. But there's also the accessibility aspect, right? We want to make sure that there's equal access for all people to emergency services, regardless of who those people are. We need to be inclusive, and GIS can help actually serve as an underpinning for that, making sure that calls from everyone get to the most appropriate PSAP and the most appropriate call taker, based on where that caller might be calling from, for example. GIS can bring the benefit of resiliency to bear, making sure that PSAPs can back each other up, that in overflow situations, policies can be enabled to overflow them to the correct PSAPs, and we know how to get those calls there, and other aspects. GIS naturally can improve situational awareness. Maps are great, and if we take those same maps and we share them out to everybody that is currently engaged in responding to an incident, that's even better. Through all of this, it can then facilitate interoperability of systems, interoperability of agencies, and interoperability of other related stakeholders. So we're going to, throughout the rest of this presentation, kind of break that down and get into some specifics of how that works. GIS, as we know, is found through the entire workflow of public safety, from when an NG Core Services stack receives a 911 call from a service provider or an app or something like that, to mapping it in a call center, showing it on a map in the PSAP, to handling in CAD, verifying the address, coding the incident, getting the right responders dispatched, having that incident show up on their maps out in the field, and have all of that data coalesced and collected inside of an RMS for future analysis. GIS permeates that entire value chain. And within NG 911, that's where we are going to focus mostly today. We have a pretty heavy reliance on that. As I mentioned before, typically we discuss location validation and call routing is the core uses of GIS and NG. And that's not, this presentation is not to diminish the importance of that. If we don't focus on those things, we don't get calls to the right PSAP at all, and that's not good. But there's a lot more you can do with GIS and NG, and that's really the purpose of my presentation here today, is to expand that notion a little bit and make sure everybody knows not only how important our jobs are and how important our data is, but what we need to do to make that happen. When we extend past that, that's where things get really interesting. For folks that may be less familiar around that typical example of getting a 911 call to the correct PSAP, though, let's level set briefly. It first involves a telecom, usually a service provider, validating a subscriber's location prior to a call ever being placed. They can use GIS data inside of the location validation function to do that, to make sure that it is in fact a quality location that can participate in call routing. Once the caller dials 911, should they do that, the call eventually makes its way through the SINET and gets sent to an emergency services routing proxy. That thing queries the emergency call routing function, or the ECRF. The ECRF is loaded with the same GIS data that the location validation function uses, and it does essentially a point and polygon analysis to determine where the location of the call is in relation to PSAP service area boundaries. And it will send a PSAP service area boundary recommendation back to the ESRP. If the ESRP chooses to use that, doesn't have policy, for example, that overrides it, it'll send it to the correct PSAP. As GIS professionals, what we care about is being able to send our GIS data, one kind of GIS data, one flavor of it, without having to transform it, hopefully, to the ECRF as well as the LVF and hopefully the PSAP. Now, as I had mentioned, GIS powers many other interoperable functions of I3. There's something called the MCCA conversion service, which handles civic address conversion between legacy and next-gen formats. It handles map display through the mapping data service. It powers interoperable geocoding through the geocoding service. It facilitates additional data discovery through the usage of the ECRF as well as the additional data repository. It can be used to help define policy rules in the policy routing function. And importantly, this one kind of flies under the radar, but this is really important, is it facilitates the discovery of services and agencies through something called the service agency locator. And it even touches and interacts with this notion of interoperable discrepancy reporting. So we'll talk about that. All these functions use the same GIS data. That is really important to underscore, that when you create GIS data that conforms to the NG911 GIS data model, that same data, through something called the spatial interface, powers that alphabet soup of functional elements that supports all of that interoperability. It also powers things on the periphery, like the call handling function and the incident record handling function at the PSAP, the additional data repository, discrepancy reports, log events, and so on and so forth. But it is that singular data set that powers them all. Let's dive a little bit deeper into then the foundation of that interoperability, right? Let's talk about each one of these kind of esoteric things in turn. The MCCA conversion service, that is an I3 functional element that provides a way to convert data to or from a legacy system that still uses MCCA valid data. So imagine a situation where you have a next-gen core services deployment within an ESINet that lives, breathes, and speaks I3. And you provision data to the ECRF and LVF using the spatial interface, and it's data that's conformant to the I3 standard, it's conformant to the NG data model standard, it's public safety grade, it's what we use to run the system. But imagine that somewhere connected to that ESINet is a legacy PSAP. It's some ancient 911 call handling system. It's been going for years. If you shot it with a shotgun, it would probably still continue to run. But it knows nothing about I3, just can't process it. So inside of the ESINet, we speak the I3 language. We marshal up our locations and we convey them in a format called PIDFlow. But that old 911 call handling system won't know what to do with it. It only knows about MCCA valid addresses. So the MCCA conversion service can be kind of used as a gateway to take that NG911 formatted address that hopefully is CLDXF compliant and convert it to an MCCA valid address that the call handling system or the CAD system or what have you could understand. And it could do it vice versa if it needs to as well. Say you're going to do an outbound transfer from a call handling system to another PSAP, it could transform it back from MCCA compliant to LVF valid PIDFlow. It also can, as the name kind of alludes to, be used to produce an MCCA from NG911 conformant GIS data as well, which is kind of an interesting topic, and that's expanded a little more in the version 3 of the I3 standard. So if that is at all of interest to folks, I would encourage you to have a look at that, and certainly reach out to all of us if you have questions afterwards. There's also this thing called the mapping data service, which is an intriguing little functional element. Its purpose in life is to provide a PSAP that's handling an out-of-area call with the information needed to display a map of the vicinity where the caller is located or get access to the data. So let's think about that example where we were talking about our grandmother in Falls Church, Virginia, who falls and needs assistance. So she calls her granddaughter who lives in Walla Walla, Washington. It might be useful if the call taker in Walla Walla, Washington was able to actually display a map of authoritative GIS data in Falls Church, Virginia, using their own data in a cartographic representation that they were familiar with, there's no way to really do that elegantly today. We do have commercial non-authoritative mapping services out there. There's a myriad of them we all use every day on our desktops and our smartphones. But that data isn't authoritative, and that data really can't be expanded to include things we may envision in the future in NG911. The mapping data service is meant to solve that. For the more technically inclined folks, their conversation, it is a web feature service that is OGC compliant that can either be used to obtain an image of what the map looks like for a given extent, or the actual features themselves, so that it can be rendered within a 911 center's explicitly defined cartographic representation. I think that's pretty cool. Not only is it cool because it just gives you access to map data with the attribution behind it, it also gives you access to that feature data itself. So an enterprising call handling or mapping vendor could elect to do some pretty interesting analysis just by querying the data of another PSAP. Now, it's important to note that all of this stuff is governed by data rights management policies and access policies, and is credentialed through the use of something called the PSAP credentialing agency, which issues NG911 certificates that identify the roles and responsibilities and, frankly, the identity of all of the players within NG911. So not only are bad actors not going to get that data, you as a PSAP that hosts a mapping data service can control what kind of data others get to see. So it's not like it's free for all. So I think that's really important to underscore. Shameless little plug, at some point we will be actually ginning up a mapping data service work group within NENA to talk about some of the technical and operational issues that surround that. Not exactly sure when that's going to come to pass. Maybe that would be later this year, perhaps early next year, but keep your eyes peeled for that. I think that's going to be a really interesting one. The geocode service works in much the same way. The geocode service is a I3 specified functional element that, as the name implies, stands up a web service that can provide geocoding and reverse geocoding capabilities within and among BSI nets. So, riffing off of that example of Grandma in Falls Church, Virginia, if she's able to tell you, the caller is able to tell you, my grandma is located at 123 Main Street in Falls Church, Virginia, wouldn't it be great if we could actually geocode that address against the authoritative GIS data and utilize the geocoded location perhaps for call routing purposes or call transfer purposes? That is something facilitated by the geocode service, and it's provisioned with GIS data just in the same way that the CRF and LVF are, and these other elements through the spatial interface. There's also the additional data repository. It may not be used necessarily to facilitate legacy integrations or call transfers, but it certainly is used to facilitate enhancing situational awareness. It's a way that entities like a PSAP can discover additional data. Perhaps that additional data is about the call itself or the caller or the location at which the call or incident is taking place. The ADR, the additional data repository, is the database that holds all of that stuff. And there could be multiple ADRs. There could be many, many, many of them. How you get data out of it is by dereferencing a URI that points to the data within it. Well, where does that URI come from? That comes from something called an identity searchable ADR, where maybe you search for additional data by a phone number, for example, or a SIP address. Or you query an ECRF. That's how you get additional data about a location. That's where your GIS data comes in. You can actually attribute site structure address points with these additional data URIs. And you can query the ECRF with a special service URN to say, give me the additional data at this location, at this address, or within an area, and return it back. Now, nothing really constrains or limits the format or content of that additional data, but the mechanism is standardized so that if you were a PSAP in Washington, you could query for additional data in Virginia. And so long as you were allowed to do that by that PSAP, the mechanism is established and you can do that. So here's an example of how that works. The call or incident handling function will query the ECRF with that special service URN. It's going to return back one or more service URIs that are actually additional data URIs that can be dereferenced against an ADR. When you dereference those URIs, back comes the data. That could be, for example, information about the location of a defibrillator within a building. It could even be something like fire pre-plans, which could be really, really useful. I heard about a situation last year that actually took place a number of years ago in 2013 at a fertilizer plant explosion in the town of West Texas. Most of you might be familiar with that, but it was a tragic event that involved a multi-agency response to a fire that had then resulted in an explosion at the plant. 15 people died as a result of that. 12 of them were first responders. Come to find out, the pre-plans for that facility were never used. They were housed in separate, one set was in a separate room at a center, another set was in a separate building. They were on physical pieces of paper. They were not accessible in the field. They were not accessible across jurisdictional or agency boundaries. So you have a lot of people rolling up with lights and sirens to a fire. They really don't know what they're getting themselves into. Whereas if they would have had access to those pre-plans, who knows what the outcome would have been. Maybe a few of those lives would have been saved. You could use something like the ADR with the UCRF to discover pre-plans about locations if that was built into your GIS data. So this is another example of a facility where the data you maintain that powers NG911 can facilitate interagency response, mutual aid, and enhance situational awareness across those traditional barriers, breaking them down. There are a few more things I want to talk about. One of them is the policy routing function. Normally we talk about policy routing using a few classic examples, like maybe a PSAP gets overloaded by calls. And there's a policy that when that overflow happens, you send calls to a neighboring PSAP or you send it somewhere else within your state, for example. Those rules that you set up inside of a policy routing function can involve spatial operations as well. That's where GIS data can come in. You could define something that says, for example, we want to temporarily reroute calls that come in from a specific location to a mobile tactical PSAP. Maybe that's handling a state fair, for example, something like that. The service agency locator is one of the most important ones, I think, because that really does glue the I3 architecture together in a lot of ways. The service agency locator is this thing that allows one agency to discover another agency and or the services that it utilizes. Think of it kind of as a search service, a directory service, right? If that PSAP in Walla Walla, Washington needs to figure out how to contact the Falls Church, Virginia PSAP in a non-emergency fashion, or it needs to maybe look for its mapping data service or its geocoding service or the endpoint at which you can subscribe to its EIDOs, the IDO interface. It can do that through the service agency locator, which, just like the additional data repository, works in part by using the CRF. You can find an agency's service agency locator record by querying the CRF with the special service URN, which directly facilitates interagency collaboration and interoperability. From a boots on the ground GIS perspective, what that means is that your service area boundaries could, for example, be aggregated into a boundary representing the ESINet, which perhaps has its own agency locator. The discrete PSAPs would have that as well. And they would simply be boundaries that would have another URI that would act as though it is the service area locator boundary, returning the appropriate URI to the service agency locator record. That might be something that your NG Core services vendors do on your behalf, and you may not necessarily need to do it as a GIS professional, but I want to flag it as something that is not only critical to the operation and functionality of I3, but is something, again, that is powered by GIS. I want to talk about, last but not least, discrepancy reporting. This is a little bit of a different spin on things. The discrepancy reporting service is a web service that facilitates the exchange of manual and automatically created discrepancies between stakeholders that can fix them. It does that for databases, services, and agencies, and most, if not maybe all, functional elements are able to generate these automatically, and they can be generated manually as well. GIS data isn't used by the discrepancy reporting service per se, but the discrepancy reports that can be filed can very commonly be location based or at least location related. So for example, you might provision GIS data to an ECRF and it detects that there is an unintended gap or an unintended overlap. The ECRF then may automatically file a discrepancy report, which could be received by the GIS data provider. Maybe that's a steward or a maintainer that can receive that and see automatically, okay, this is what happened, and collaborate with individuals as necessary to get that resolved. There's a document, it's a requirements document that was published a few years ago that talks about at NENA that describes discrepancy reports and some of the business and operational guidelines around them. And they're usually states for most of them that they should be resolved in 3 business days or less. But the key to here is that there is a interoperable mechanism developed to submit and transmit and convey these discrepancy reports, regardless of whether or not you're using vendor A, B, or C for your NG core services. And I think that's really cool. And it directly relates to, again, GIS acting as the underpinning of interoperability as a way to discover where this web service is that you post your discrepancy reports to, much less resolving issues in GIS that may have been flagged by a discrepancy report. But when we get ourselves out of the alphabet soup of the NG core services stack, we start to ask ourselves, what about the other things? What about our other friends that we haven't been talking about as much? We don't want to leave PSAT mapping, CAD, mobile, and RMS out either. GIS, of course, is used in all of those things, and interoperability powered by i3 can help as well. Whether or not you're using EIDOs to transmit incident data back and forth and you're figuring out where to send it based on GIS data, or you're simply, emitting data through a mapping data service that could be consumed by these applications. GIS can act as the substrate for interoperability in these as well. And I'm pretty passionate about seeing that actually happen, because nothing makes me sadder, I think, than GIS data being in silos. And the i3 architecture can help break those silos down. So how do we get there with all of this? Naturally, like anything, it's going to take work, and we're familiar with getting our data ready for initial call routing and location validation. But where do we start? The traditional place was and still is location validation and call routing. But then what about the rest? What about the mapping data service, the geocoding service? What about the service agency locator and all of this stuff that I've been talking about today? A lot of it depends on the capabilities of your service providers, whether or not that's your NG core services provider, or it's your providers of your PSAP software or the software you use in your field units. Is it ready to use those new functional elements? What is their roadmap? And by extension, then what is your own roadmap for that? Maybe some of that stuff isn't really important to you right now, but when you start doing ESINet interconnection with your neighboring agencies, it will absolutely become important. So I say all of this, if for no other reason than to get it on your radar so that you know what's coming and that your GIS data will be used for more than just getting a call landed at the correct or most optimal PSAP. I also want to state, of course, that all of us in the industry are willing to help with this, whether or not that's our host today, Datamark, whether or not it's NENA, whether or not it's the other organizations within the industry to help ourselves out with that. We're all in this together. We all want to make sure it succeeds. So I would very much encourage everybody to work together on this. Where can you go from here? There are some ESINets and NG core service implementations that have been stood up where data is not yet CLDXF compliant. That's probably a great place to start, because inevitably that will happen. You might start thinking about implementing a spatial interface to provision data, not just to the ECRF and the LVF, but all of these other things down the road, like the mapping data service and geocode service. It's far less exciting to have to engage in proprietary provisioning mechanisms where maybe one of those things you upload a zipped up file geodatabase to a secure FTP site, and another one you're like exporting data to a proprietary GIS data format that you then email to some person who loads it in to a separate system. That creates not only a lot of work for you on the provisioning side, but it also means you probably have data currency gaps where one system has newer data than the other, and that's not great. So that can be a natural place to start. Think about the additional data aspect. How can you leverage this to prevent future disasters from happening, like the fertilizer plant explosion in West Texas? Could additional data be useful in your jurisdiction? Could it help other jurisdictions who have to provide assistance to you or field your calls if your PSAP goes down? That could be something really valuable to think about. Could you already use an ECRF maybe that you're using today to perform geospatial selective call transfers? So you're not just using it to provide an initial route to a PSAP, but you're using it to provide an optimal route on the outbound for a transfer. That's a pretty easy, low-hanging fruit sort of a thing, and a lot of call handling systems support that now. So that's another thing to think about. But more importantly, just start thinking how you're going to get there. How do you define that roadmap? What's most important to you? And what's that going to look like as it impacts your GIS and 911 authorities organizations from a time perspective, a staffing perspective, an effort perspective. It may not be much, but it's something to start thinking about. So today we learned a few different things. We learned about what interoperability means in NG911 and why standards matter. It doesn't work if you don't have standards. We learned that GIS plays a pretty foundational role in a lot of stuff, not just getting a call to the correct PSAP. And we shared a few suggestions on what to do next. Fairly high level stuff, but good stuff nevertheless. So I wanted to say thank you and encourage you to reach out if you have any additional questions. We do have time here though, Jeff, to field some questions, and I believe there are some in the chat box. So if you'd like to go ahead and share any questions that you have, now would be a great time to do so.
Yeah, absolutely. Appreciate the presentation, Brooks. The first question we have here in the Q&A says, just for clarification, we can find the correct PSAP to get grandma help in Somewhere Falls, Virginia, and transfer the call, right? Not just call the PSAP and relay the information.
Yes.
Great.
And I think that's the key. When we get to the place where we have interconnected ESI nets, you're not just calling the PSAP, you're literally transferring the call, and you're transferring it with all of the data you've gathered so far, including locations. Any notes you may have been taken can be passed along in the emergency incident data objects. And if you need access to, excuse me, some of the authoritative data that might be in Virginia before you transfer that call, you've got access to that too. You're sending the call along with a valid address, for example. So much more than we could ever do today.
All right, great. That is a good point of clarification, because that is really the way that the standards are intended to address the struggle, right? Is to make that gap, not just call and air gap information to them, but actually send all the information that they can across interconnected ESI nets so that they share the important stuff.
Yeah.
Great. Another question here. Everyone loves the standards that NENA has been working on for many years. As NENA works on more standards to include standards for Canada and international calls, US data in the English units. US data is in the English units. Could the next generation 911 system and something like the mapping data service have potential problems if some GIS data is in the metric system and other data is in the US standard system, speed limit, area of special event boundary, offsets from an XY coordinate, et cetera?
That's a really, really good question, and one that actually did not come up when a few of us crafted an issue submission form that we submitted to NENA a few years back, suggesting that we start this working group to explore technical and operational considerations around the mapping data service. And I think that would be a perfect one to explore there. Nothing in the data necessarily would probably have to worry about, converting those units, but it would have to probably note what the units were, right? So that a consuming system could better understand them, right? So, if there was a system in the US that was sent a call from Canada, that it could properly understand the units in there, or if a PSAP in the US was looking at Canadian data in a Canadian mapping data service, that it would be interpreted appropriately within that software, right? You could totally imagine a situation where an enterprising vendor, a CAD vendor, would decide to develop mapping data service integration capability within their unit recommendation engine. So for its run cards, its response plans, what have you. And maybe it could take into account data that comes out of the mapping data service when it makes its calculations, and it would sure help if it understands that the speed limits were, for example, in kilometers per hour instead of miles per hour. So that's an example of where we, maybe we need to do a little more augmentation of the standards to allow that. And I think it's a really good point. Thank you for raising it.
Great. Talk a little bit, this question is a little bit about the role of a standard versus like an information document. He says there are plenty of great standards out there, but are there any good documents that outline more of an NG901 implementation roadmap?
It's a really good question. There are some older documents, like INF documents and such, that are purely informational, that do talk about NG911 implementation roadmaps. I mean, certainly there's materials that come from the National 911 Program Office as well. And after the call, I'd be certainly happy to provide references to specifically what those are. No doubt there are more opportunities to enhance that documentation. And it would be interesting to maybe have a discussion at some point to figure out where there might be gaps in the documentation that's been constructed thus far, and where we might need to put a little more attention to.
Yeah, and I'll put a plug in there for a document that I'm co-chairing the working group on, the informational document about transition of GIS data or GIS data maintenance during transition phase, that I think will begin to kind of solve some of that, especially around GIS data. It obviously doesn't stray into implementation of functional elements and things like that, but so I know there's a lot of documents being worked on, information documents that are there and intended to help sort of interpret some of the standards and operationalize them for readers.
Yeah, and this brings up an interesting point, Jeff, because I know that we have similar documents elsewhere. The NG data flow document is a good example of that, trying to, say the kind of data that we get in an E911 system for an alley, for example, is found within different parts, within different data structures from different systems in I3. I think we probably do a pretty good job about building these like lower level, more detailed transition documents, but maybe we need to bubble them up a little more, or at least make sure that the higher level ones appropriately reference those things accordingly. Although I'm not an expert with those higher level transition documents, I'm sensing there might be an opportunity to button that up a little bit.
It'd be interesting to have something that does that at a high level, helps connect the relationships not only between the recommendations of the documents, but the documents themselves, so you kind of understand them in a logical workflow sense. Yeah, I like that idea.
Yeah.
Couple more questions, Scott. Just to follow up from Scott, is that document published yet? It is not published yet, but it is in its final review stages. It's about to, hopefully it'll be in public review in the next few weeks, and we can get it published as quickly as possible. Another question here. Will the NENA enhanced PSAP registry eventually have whether a PSAP is NG901 I3 compliant, or does it matter? We have access now, but I'm not sure. But I'm not sure how widely it's being used around the state.
It's a great question. I am fortunate that I'm able to devote a pretty significant chunk of my day-to-day work stewarding the EPRC myself. And I'm very excited to be able to collect data just like that. There's a lot we can be doing from the census portion of the enhanced PSAP registry and census to collect that kind of data. And although it might be a few months out yet, I'm really excited about trying to reboot that effort and expand it and really try to take that census portion to the next level. That's going to involve outreach, of course, to the agencies that already use the EPRC, but then to the agencies that don't use it yet, as a way to not only help them understand the benefit of being able to access it, and it is free for all PSAPs to access. So it's a great tool to have at your disposal. But then as a way to solicit some of that additional feedback about who's NG, who's not, what degree of NG is it? Do they just have an IP ESINet, or are they doing full-blown geospatial call routing? Do they support native RTT termination? The list goes on. There's a ton of data that we could collect there, and I think there's some natural intersection with something that the program office has done called the 911 Data Path Initiative. I don't know how widely it's known. For folks that haven't checked out the Data Path Initiative, I would encourage them to have a look at it. It's an effort to try to standardize the kinds of data that would be useful to collect about PSAPs and their operations and the challenges they face, and then paint a statewide and national, ultimately, picture of the lay of that landscape. There are visions down the road of having an actual database built that has this information, and web service architectures that allow that data to be submitted and whatnot. It might be a little ways until we get there, but I think that's kind of the end goal, and the NENA EPRC might be able to play a bit of a role in helping facilitate that as well.
Yeah, vision is key, right, to accomplishment. There's a question here about the recordings of this presentation. My understanding is that they will be available, and you should see an email in the next coming weeks, when they're all prepared, and where you can access those. So that's all the Q&A box holds for us, but I got a couple of things, since we have a couple more minutes.
Sure.
Just kind of something that we were talking about leading up to this is that I'd love for you to share your perspective on is what you've done here today is really demonstrate that the development of this local authoritative GIS data is not just about call routing, initial call routing, or even call routing in general, but it's used throughout the entire NG911 ecosystem. I've heard comments or questions at different events and opportunities where somebody suggests that there's probably some other location technology that's going to come and replace the need for GIS in next gen 911. But I think what you've demonstrated is that there's much more than just call routing being done with GIS. Could you kind of share a perspective on that?
Yeah, for sure. I mean, certainly throughout our future, we're going to see new location determination technologies, right? Better ways of figuring out where we are on the X and Y plane and where we are on the Z axis as well. We'll have better technologies that can reflect dispatchable addresses indoors, because humans, of course, don't think in X, Y, and Z usually. A first responder certainly doesn't. But at the core of all of that, I think what is static, at least right now, and probably will be for a very long time, are things like jurisdictional boundaries, PSAP boundaries, and the location of an incident, right? If there is an incident taking place, it will always have a location, unless that incident is completely fictitious and it's within the metaverse, right? We are human, we are at a place, right? Even in the situation where maybe in 100 years, there's a single national PSAP, which I don't think in the US would ever happen, but imagine that happened. It still has a boundary. Other nations have boundaries. We need to figure out if a call or a caller is in Canada or the US, or if grandpa in Lithuania needs assistance. How do we get a hold of Lithuania, right? So I think GIS, and maybe more broadly, just the notion of location-based response is a pretty consistent thing, but the way we choose to build the data to support it may very well evolve. And certainly the location technologies and methods of location conveyance will probably evolve quite quickly as well.
Yeah, I think I like what you just said there, basically that the development of the GIS data we're going through now really serves as a foundation for the other things in the future that will probably far exceed, geospatial call routing, but every other support aspect of first response. The other thing I heard you talk about, if I could just sort of like sum it up a little bit, is that a lot of the data and the elements, the MDS, the GCS, even in the ADRs, the value proposition of the effort going on to develop GIS, high quality GIS data for these functional elements is about it being local and authoritative, right? It's not built for the purpose of selling ads. It's not built for the purpose of routing packages. It's not built for the purpose of delivering envelopes to structures, but it's built for the purpose of 911 and first responders and emergency response. Is that an appropriate way to kind of sum up the value proposition?
Yeah, I think so, and I think about that in terms of local knowledge, right? If I'm the 911 administrator, or even just a boots on the ground GIS professional in Murray County, Minnesota, I know Murray County, Minnesota a heck of a lot better than someone at some corporate GIS company does, right? And that's where that local knowledge, that local authority is key. And I think that is, that's really the underpinning of all of this, is serving the value propositions that NG911 brings through interoperability by using that authoritative data that's collected and curated at the local level, and of course aggregated up through other hierarchies, but it all starts at that local level.
Great. Well, I think we'll give everybody a few minutes before the next presentation starts up. In the chat, there is an attendee link for the next session, which is the 311 of 988 for 911. A lot of 3 number combinations there. So join in. That one's going to start up at 9 o'clock Pacific. And listen, Brooks, really appreciate the informative presentation and the work that you put into it and the work that you're doing there with NENA now. And thanks for being a part of the Datamark Orbit.
Well, thank you for having me. This was a pleasure. I really appreciate it.
All right. Everybody, have a great day.